Applications of differentiation, related rates practice A. Each side of a square is growing at a rate of 5 centimeters per second. What is the rate at which the area of the square is growing when its side length is 10? As mentioned, we have related rates here, so let's design a couple variables. T equals time is always going to be useful. We're also going to have L for the length. And lastly, we're going to have A for area. Now, the question wants the rate at which the area of the square is growing. This is the same as asking for dA over dt, area changing with respect to time. And by related rates, this is equal to dA over dL times dL over dt. In order to find dA over dt, we're going to find each of these two individual products. Let's start by noting that dL over dt is clearly given to be 5. So let's just write that in. dA over dL is a lot more interesting. We have that a as a function of L is just L squared. This means if I take the derivative about a or about L, then a prime or dA over dL is just 2L. Because L is given to be 10, this is just 2 times 10, which is 20. So now we have both components. dA over dt is just 20 times 5, so that gives us our final answer of 100, but the unit is in area per time, so that's 100 centimeters squared per second. And that's our answer. Looking at the solution, notice that we had to write dA over dt in terms of a couple components. We had to write it as dL over dt, which is here, times dA over dL, which is this first term. dA over dL is just the derivative of L squared, so that's 2L. We found this because the area of the square is L squared. So by taking the derivative about A, we got dA over dL. Lastly, we just plug in and we get 2 times 10 times 5, that's 100.